Let's have a look at this question together. So they said you have 10 moles of hydrocarbon, which is CXHY, reacted with oxygen, and we know CXHY, hydrocarbons. With carbon and hydrogen, the product is definitely carbon dioxide and water. Okay, so they said that there's a contraction in volume, blah blah blah. When the product treated with sodium hydroxide, there's a further contraction. I ask you to deduce a formula. Okay, so let's write down the balance equation first. Always treat the most complicated product as 1. And because it's CXHY, you have X moles of carbon and Y moles of hydrogen. X moles of carbon all goes to carbon dioxide, so there's X here. And then Y moles of hydrogen, each water has 2 hydrogen molecules, so we put a Y over 2 here. Okay. And also, the amount of oxygen on the right hand side is 2X from carbon dioxide and Y over 2 from water. So this is the amount of monoatomic oxygen. Okay. However, the oxygen gas you have here is diatomic. Yeah, so you need to divide everything by a 2, which is x plus y over 4, right? So the balance coefficient here is x plus y over 4. So this is our balanced equation. And then they said the product, which is carbon dioxide and water, is going to react with sodium hydroxide. Okay, so we know sodium hydroxide doesn't react with water. Sodium hydroxide only reacts with carbon dioxide. Yeah, so these two react together, form some kind of product. Okay, it would be in a solution, so it's aqueous as well. Carbon dioxide is a gas. NaOH is aqueous. Your original hydrocarbon is told you 10 moles, so you know it's a gas. Oxygen gas is definitely a gas. Carbon dioxide gas is definitely a gas. One of the assumptions you must make for this question is water in this case is a liquid. Okay, otherwise, this question is impossible to do. So you need to assume that. Yeah, you need to assume the water is liquid. Yeah, and then one of the common sense we know compared to gas, yeah, the volume of the solid equals to the volume of the liquid equals to the volume of the gas, which is 0. Okay. So the volume of aqueous. Yeah, so the volume of aqueous, liquid, solid, they all negligible compared to the volume of gas. So for example, 10 moles of hydrocarbon, the volume of the solid is probably 0.01 moles, which is negligible. Okay, we can completely ignore that. So they said when carbon dioxide is treated with sodium hydroxide, there is a further contraction of 30 moles. So all these 30 moles of construction, this is 0 volume, this is 0 volume. Yeah. So all the volume contraction is from carbon dioxide, means the amount of carbon dioxide you started with is 30 moles. Okay, it's all used up. Therefore, in the end, you have 30 mole contraction. Okay, so this is your limiting reagent treated with sodium hydroxide. Sodium hydroxide is largely in excess. So all carbon dioxide is all used up, and it contains 30 moles. So if we start with 10 moles of the hydrocarbon, form 30 moles of carbon dioxide, we know the volume ratio is exactly the same as mole ratio. Okay. So if their mole ratio is 1 to 3, then x equals to 3. Okay, then x equals to 3. Yeah. So we can have a look at this equation again. So it's C3Hy plus 3 plus y over 4 O2 goes to 3 carbon dioxide plus some kind of aqueous. Yeah, so we know water is a liquid, it doesn't, some kind of liquid. It doesn't take any volume, so we don't really care about it. Liquid has 0 volume. Yeah, so they told you there's a contraction of 30 moles. Yeah, so 30 moles means this is 10 mole, this is some moles, this is 30 mole. Okay, yeah. So when all of this used up and subtract the amount of carbon dioxide, the contraction is 30 moles, which means the amount used minus the amount formed equals to your total contraction. Right. So the amount you used at the beginning is 10 moles, and then plus amount of oxygen used. Yeah. And how many carbon dioxide you formed is 30 moles, and equal contraction, which is 30 moles. So we can work out the amount of oxygen used is 50 moles. Okay, so you start with 50 moles of oxygen all used up, 10 moles of hydrocarbon all used up, and so you use up 60. However, you do form 30 moles of carbon dioxide, means the total number of moles gas volume you use is 30 mol. Okay. 30 moles the overall used in total. Yeah, so if the amount of oxygen used in total is 50 mol, so this one here would be 50 mol. Okay. Yeah, so 50 mol compared to this 10 mol. Yeah, so if their volume ratio is 10 to 50, their mole ratio is 1 to 5. Okay. So 5 equals to 3 plus 2. 3 correspond to this, 2 correspond to this. So 2 equals to y over 4. Y equals to 8. Therefore, the final product is C3H8.